Hello everyone. Today I'm going to talk about adsorption of copper and cadmium by fly ash-based geopolymers. My name is Teresita Medina and this is my thesis subject direct by Dr. Paola Arredondo from Universidad Autónoma de Sinaloa. Industrial wastewater have led to serious environmental problems caused mainly by heavy metal pollution. A commonly used method for wastewater treatment is adsorption, which is simple and efficient. Zeolites and activated carbon are frequently used as adsorbent material. The optimal adsorbent characteristics are high porosity and a specific area. However, since these materials are more expensive, scientific community is interested in new adsorbent options. On the other side, some byproducts from other industries, such as fly ash, have some disposal problems due to a large production that ends in huge landfills. By this waste, it is possible to synthesize geopolymers that have a good porosity qualities that make them an economic, efficient, and eco-friendly option. Geopolymers are the amorphous equivalent of zeolites because they are three-dimensional inorganic polymers of alkaline aluminosilicates constitutes of chains of silicon oxide and aluminum oxide tetrahedrals and linked together by shear oxygen atoms. Zeolites are highly crystalline and geopolymers are mainly amorphous and semi-amorphous. The network that constitutes these materials is negatively charged due to aluminum being linked to four oxygens. This charge is compensated by cations that are trapped in the intracrystalline spaces. These ions are easily interchangeable, and this peculiarity gives the geopolymer the ability to attract ions or heavy metal ions. These characteristics are mainly affected by the change of pH, temperature, initial concentration, and contact time. The fly ash used in this study is a F-type fly ash that was passed through the mesh number 325. For the alkali activator solution, a mix of sodium hydroxide pellets at H molar and sodium silicate solution with modulus of 2.H was used. They were mixed together for geopolymerization in following conditions: silicon aluminum ratio of 2, sodium oxide silicon oxide ratio of 0.25, and water sodium ratio of 10. The geopolymer slurry was cast into a plastic molds and subject to a hydrothermal curing process. One of them was labeled as G6 and it was performed in oven at 60 Celsius degrees for a period of time of 24 hours and followed by water submerged curing process at 25 Celsius degrees per 6 days. The second curing process was labeled as GH and it was performed in oven at 80 Celsius degrees for a period of time of 3 hours. After geopolymerization, samples were washed and dried for subsequent absorption tests, which were performed by batch adsorption operation at constant temperature of 25 Celsius degrees for a period of time of 6 days in a volume of 40 milliliters and dosage mass of 0.5 grams at initial concentration of 5 parts per million, varying pH at 2, 4, 6, and H. The uptake percentage was calculated by the following formula: initial concentration minus equilibrium concentration divided by initial concentration. The result 100 times. Results. X-ray fluorescence of raw fly ash shows that the main content of this material is silicon and aluminum, which makes it a great aluminosilicate source in geopolymerization process. The X-ray diffraction shows that the main peaks of fly ash is quartz and mullite. These phases are also appear in both geopolymers, but we can see that geopolymers got more new amorphous phases like analcime and ausignite, which makes the geopolymers more porous. Compared between two current processes, we can observe that less temperature leads to more specific surface, more pore volume, and pore size. The Fourier transform infrared spectra shows the bonds corresponding to mullite and quartz around wave number 700 and 800. Around wave number of 1000 corresponds to silicon oxide, silicon or silicon oxide, oxygen aluminum bonds, which are the main bands of aluminosilicates. New bands found in geopolymers in its oxygen carbonate oxygen bonds. This band indicates carbonation formed after geopolymerization. Bands around wave number 1600 and 3500 corresponds to water physically and chemically linked in the geopolymer. In the last, adsorption test graphs shows the influence of pH in adsorption capacity. For cadmium and copper, the uptake increased when pH increased until a pH of 6. The best adsorption condition is at 6 pH. At lower, the heavy metal isn't in ionized form, which affects the correct flow of the ions through the geopolymers pores. In both cases, the uptake reached upper 90%, which indicates that geopolymer is a good option as an absorbent of cadmium and copper. Thank you so much for your attention.